Ever since the carbon dating of the Shroud in 1988, the focus of the authorities has shifted away from the issues of authenticity to issues of conservation. Nevertheless, because many questions remain regarding the Shroud and the exact nature of the samples used to date it, the issues surrounding conservation are intimately interwoven with its history and subsequently with questions related to its authenticity. In any analysis of the conservation question, one must be concerned with the presence of catalysts on the Shroud which might contribute to further deterioration of the cloth and its image. The most obvious of these is the presence of the burns and the burn shards. The quickest and easiest way to remove these would be by the wholesale and total vacuuming of the entire Shroud. Hence, the obvious question is, should it be done? What secrets are locked up in the dust particles still on the Shroud? What kinds of particles are there? No complete catalog of these particles yet exists, and with the exception of some brief lists, may I have the first slide, please? No, I'm sorry, hold the slides just yet. None has ever been published. What kinds of distribution patterns are extant on the cloth? No technology has yet been applied to the Shroud to determine such distribution maps. Are there material traces that would help resolve the painting controversy? In private conversations with Dr. Alan Adler, he has pointed out that we know next to nothing about the microbiology of the Shroud. Clearly, any wholesale vacuuming of the Shroud would permanently remove all further clues to the Shroud's past history, and thus any possible information about these questions. I thus firmly believe that we must broaden the question of conservation to include the conservation of the information inherent in the dust particles and their distribution patterns on the Shroud. I wish to explore this in some detail in this paper and then present a suggestion for the proper approach to vacuuming. Pigments and pigmented fibers. Since 1986, I have been involved with the creation of a catalog of particle types on the Shroud. The aim of this catalog has been to gain the kind of knowledge we need in order to properly direct our attention to the kinds of specialists who should be involved with the further analysis of the dusts. This paper will not try to address a composite picture. Indeed, no composite picture can yet be developed because the survey work and cataloging is not yet finished. But suffice it to illustrate my case by drawing on a small fraction of data from the catalog as it currently exists. In 1981, Heller and Adler suggested that the presence of trace vermilion pigments might be attributable to the fact that artists have copied the Shroud. Macron has countered that he and Skirius made a count of iron oxide pigment particles and fibers and have found them statistically related to the image on the Shroud. The difficulty with this explanation may lie in the history of the Shroud. Don Luigi Fossati has made an excellent and extensive study of a special group of paintings known as true copies, and has shown documentation that as many as 52 of them were directly touched to the Shroud. Therefore, in February of 1986 at the Elizabethtown College Conference in Pennsylvania, I suggested that one possible explanation for the presence of Dr. Macron's findings of iron oxide intimately associated with the image area from the Shroud was the possibility of the shedding of such pigments from these true copies. Can such shedding have occurred? Change. First slide, please. I have found fibers on the Max Fry tapes that I suspect may well fall into this category. Ms. Isabel Pixek has explored this question further and will provide important experimental details supporting this. Discussions with Dr. Adler indicate that the technology now exists to determine the fingerprints of the pigments and fibers of the existing true copies if one were to make a collection of such controls from the extant copies. Using such a database, it would be possible to clarify and classify the pigmented fibers and their types on the shroud, and thus provide a scientific base and alternative explanation for the presence of iron oxide particles and pigmented fibers to contribute toward resolving the painting controversy. Indeed, this long-term project may be said to have begun. Already, such samples have been preserved from a true copy now kept in Summit, New Jersey, at the Monastery of Our Lady of the Rosary, dated to 1624. But wholesale removal of all dust from the shroud would erase the off-image distribution pattern that may still exist. Fungi. Dr. Max Fry noticed that there were many fungus spores on the shroud, but his interest lay in the study of the pollen, and he did not elaborate further. Thus, very little is known about the presence of fungi and their types on the shroud, but several specialists have verified for me that they are there not only in spore form, but also in the evidence of hyphae from the fungi themselves. Entomology. Dr. Rigi has already made available scanning electron micrographs of insects in his previous public contributions. There is ample evidence of insect parts also on the shroud. Change. But there may be not only members of the class Insecta, but also of Arachnida. A number of finds not yet identified illustrate this virtually unexplored field of microbiology. Change. Botany. By far the greatest representation for the study of the microbiology of the shroud is surely in the plant particles. The anthers, such as you see here, filaments, change, bracts, such as this slide, change, cellular material, plant hairs, stellite growths, fragments of sepals, and of course, change, please. The millions of pollen that currently exist on the shroud. Is there a significant distribution pattern in these particles? One illustration must suffice. At the New London, Connecticut conference in 1981, Dr. Giovanni Rigi made public his findings of mineral-coated pollen grains in the dust taken from the non-image side of the shroud. On the evening of November 21st, 1987, I had dinner with Professor Luigi Ganella, and later Dr. Rigi joined us for the discussions. The photographic survey of the particles on the Max Fry sticky tapes had already begun in 1986, and by then I had already assembled photographic documentation of 163 pollen grains on tape 4BD taken from across the blood rivulet on the anatomical left arm. These were done at 200 power. Because I was interested in being able to identify the mineral-coated pollen from the shroud, I asked Dr. Rigi to examine the 163 pollen micrographs and identify for me those that he believed were mineral-coated. When he had finished his examination, he told me that out of 163, only one might be mineral-coated, and even of that one, he was doubtful. So I asked him, what percentage of pollen samples from the non-image side of the shroud were mineral-coated? His answer, 50%. I was astonished. I had no explanation for why fully 50% of the pollen in Dr. Rigi's samples would be mineral-coated, and very nearly all of the pollen samples from the image side be mineral-free. Clearly, here is a distinct, significant particle distribution which bears further investigation. In my forthcoming book, The Shroud of Turin, a case study in document authentication, I explore this in somewhat fuller detail and suggest that this lends support to the case for authenticity, since such a find is consistent with the moist environs of the tombs in Jerusalem. Burn shards. Change, please. It might be argued that even if the shroud were wholesale vacuumed, the material thus removed could still be saved and studied. The point I wish to emphasize here is that the potential information is locked not only in the physical material itself, but rather in such material and how it is physically distributed on the shroud. It is the latter that would be lost irretrievably if we would resort to wholesale vacuuming. I can make this point with one final illustration. I owe this observation to Dr. Alan Adler and thank him for his permission to use it. At a private meeting, the Archive Committee of the Holy Shroud Guild in 1992 in Esopus, New York, Dr. Adler mentioned the curious peculiarity that none of the radiocarbon labs ever published having found any traces of burn shards on the samples removed from the shroud for carbon dating. He noted that in his studies of the Stirp tapes, these burn shards were ubiquitous over the entire area of the shroud represented by those tapes. When I returned home, I examined a map of the Stirp tape sites and discovered that none had been removed from the side strip area of the shroud. Thus, I reasoned, it might be possible that perhaps the burn fibers had not been transported that far away from their original scorches during the repeated folding and rolling of the shroud over the centuries. But there was an immediate way to test this hypothesis. Therefore, over a period of several microscopy sessions, I re-examined the Max Fry tapes. It is fortunate that Dr. Fry took 8 samples from along the side strip, and one of these, a sample labeled 2AA, came from a location not far from where the radiocarbon samples were taken. On every single sample of the Fry tapes, including all 8 of the side strip samples, we find evidence of the burn shards. Thus, these burn shards have been distributed over the entire shroud from the center to the edges. This underscores Dr. Adler's observation and his further suggestion that this might lend support to the hypothesis that this particular area of the shroud had once been possibly rewoven and therefore would be cleaner than other portions of the shroud. Indeed, this, quote, cleanness, unquote, of the radiocarbon sample area is attested to by a letter to Remy van Helst, who has kindly given me a copy, from Dr. Willy Wolfle, lending even further support to Dr. Adler's observation. But before we conclude that such burn shards were not on the radiocarbon samples, we must give careful consideration to other possible reasons for why the laboratories might not have recorded such materials. Perhaps other labs did observe such shards, but just simply did not record it. Moreover, the methodology used often affects the gathering of data. For example, using top lighting with a zoom lens, it might be argued that at the low magnification powers employed, one might not notice the presence of such contaminants. Indeed, I examined the microscopy transparencies kindly made available to me by Barry Swartz with the generous permission of Mark Evans, especially with these burn shards in mind. The highest power at which their photomacrographs were taken was 64 power. I was not able to visually verify the presence of burn shards on any of those macrographs, in spite of the fact that many of them were taken in the same areas from which the Stirp tapes were removed. Using transmission lighting, such as that employed by Drs. McCrone, Heller, and Adler, and myself, at higher powers, such burn shards readily show up, proving that the burn shards are present everywhere on the shroud. Therefore, the question of burn shard distribution and the possibility that they are not extant in the radiocarbon sample area merits further careful research. The best way to resolve it with clear certainty is to re-examine the area around the Raz corner to establish the statistical significance of burn shards. But the point here is that if all of the shroud were vacuumed, thus removing the evidence of such distribution patterns of material, this potentially important information would be totally lost. If vacuuming is done, how do we do it? As I have noted, wholesale vacuuming will remove all such crucial material and their critical distribution patterns. And the decision to vacuum is inextricably entwined with the question of whether or not the burn areas themselves should be excised from the shroud. Instead of the wholesale approach, I suggest that, if such removal is deemed absolutely necessary, it must be done selectively with a mini vacuum of a type that has been available on the market for years. Moreover, the material from each mini sample must be preserved separately and precisely recorded as to the specific location from which it was taken. True, it would take a huge investment of time, but it is the only method which could remove the catalysts and still leave the precious historical information for posterity and future science. Thank you.